Yes, what we have here is dead sound. Okay, so we're going to do motion problems today, and I'm going to kind of flash you back to how we started and we did motion problems with derivatives, and we're going to go backwards and do it with integration. So once we do it, you're going to be expected, the problems can be mixed up going either way. Okay, so it's not like, okay, now we're doing integration, so that's the only thing we'll do. It's going to go everything you used to know and add on to it what you know. So for derivatives, just to kind of remind you, you started with a positional equation. When you took the derivative of it, you got velocity. When you took the derivative of velocity, you got acceleration. And you basically just go backwards. Okay, so when you take the integral of acceleration, what do you think you're going to get? Velocity. Yeah, when you take the integral of velocity, what do you think you're going to get? Position. What's the only thing when you integrate, what is it you get that's annoying that makes you not exactly know the answer? Plus c. Okay, so you don't know the exact equation. They have to give you a point for you to be able to figure out what the c is. Okay, whereas with a derivative, you don't have that problem. You have the exact information. Okay, so gonna remind you, if you're in physics, a lot of this, I don't know, it's kind of been drilled into you. But we have to talk about the difference between position, distance, and displacement. So position is just where you are, okay? And a lot of times in the math problems, it's not exciting. You'll be on a number line. Woohoo! Okay, so you might be at 2 on the number line, you might be at -2 on the number line, but you tend to be on a number line. You could launch something in space. It could be where you are in space, but the position is just literally where you are. Now, there's a difference between distance traveled and displacement. Okay, and we've talked about this before. Basically, if I drive to school, it's 2 miles, and I drive back home, it's another 2 miles back. How far have I gone?
6 miles.
4, thank you. Okay, but what is my displacement?
2. 0.
0, because I'm right back where I started. My final position minus my initial position is 0. Okay, and that's going to matter a lot for us as far as how we calculate things with our graphs that we're going to do. Okay, so the main thing is that displacement is final position minus initial position. Okay, whereas the total distance traveled, you're going to have to add up the total movement of the particle. Okay, so displacement, just the final minus initial. You might have traveled a long time, but you ended up back where you started with. Okay, but the total distance traveled, even if you go back to where you started with, you're just adding up your total motion. Okay, so just some really simple examples to start with. It says, suppose a particle begins at 1 at time equals 0. When they say at 1, they're talking about on a number line. Okay, I told you they're not like real imaginative sometimes. It travels to the point -2 at time equals 2. And it wants me to find the initial positions, the final positions, the distance traveled, and the displacement. So I'm going to draw a little number line. And I'm just going to draw a picture of what's happening. It says it begins at 1 at time equals 0. Now you don't really have to put the time there, but I like to, so I'm going to. Okay. And then we're going to show that it travels to the point -2 at time equals 2. Now, generally speaking, you might wonder, why am I doing it above the graph? Basically, when you do a motion diagram, which is what this is, if you have a lot of motion back and forth, then if you just go back and forth on top of the number line, you won't be able to see what happens. Whereas if I'm now going to go backwards here, I might go like this and like this. I would draw it above the line so that I could see what the motion was back and forth. Okay, so that's why I'm drawing it above the thing. Okay, so it says find the initial positions and final positions. Okay, so initial position I'm going to put as SI for S initial. And what is the initial position?
1.
Yep. And what is the final position? What is, let's go, let's do distance traveled. Okay. And how do I calculate displacement? Yes, how do I calculate it? Okay, so the final is -2 minus the initial. So negative 3. So that the displacement actually takes into account the direction that you're going. The distance traveled doesn't matter whether it's forward or backwards. You're just going to add up all the distances, and that's going to be positive. Is that all right?
So can displacement be positive and negative?
Yeah, it can be either one. So if I had just gone the other way, if I had gone from negative 2 to 1, then it would have been positive. Yeah. So displacement is considered a vector quantity and can be either positive or negative, whereas distance traveled is always positive. Good question. All right. Suppose a particle begins at x equals negative 2 at time equals 0. At time equals 2, the particle is at x equals 3. At time equals 4, the particle is at x equals 4. Find the initial and final positions, the distance traveled, and the displacement. So again, I'm going to draw what's called a motion diagram. Okay, it's at negative 2 at time equals 0. Time equals 2, it's at x equals 3. You do go ahead and show an arrow. That way I know which way. Now the time tells me which way I'm going, but normally you don't actually write the times on there. It's just something I like to do. But you do, it is standard to put the arrows so that you know that you're going from here to here rather than vice versa. And then it says time equals 2, the particle is at 3. At time equals 4, the particle is at 1. Again, I'm going to do that above so that I'm not just zigzagging on top of the same thing. Okay. All right, so it says find the initial position. What is that? Perfect. Final position. Okay, so I'm going to do displacement first because it uses what you just told me. So that's final minus initial. So 1 minus a negative 2. Okay, and all that's saying is compared to where you started, you're now 3 to the right of where you started. Okay, so it's telling you where you are compared to where you started. Okay, so it doesn't tell you where you are, because you're certainly not at 3, but it tells you where you are relative to where you started. Okay, now what about total distance traveled?
7.
How did you get 7? Okay, so that distance was what? And then you went backwards another 2. Okay, so it's pretty much logic. Again, we're going to be doing this with velocity graphs, but we'll have that soon. Okay, just a reminder, the difference between velocity and speed. Velocity, which is the derivative of position, or displacement if you want to look at it that way, is a measure of how fast the particle is moving relative to a fixed point. It does have direction. Okay, so generally speaking, positive is to the right, negative is to the left, or if you're doing up and down motion, positive is if you're launching it up, negative is if it's going down. Speed is just the absolute value of that. Okay, so if you wanted the speed of gravity, what would it be? Yes, but that doesn't make any sense because that was acceleration. Whoops. Okay, so acceleration is, if you wanted to take, acceleration is negative 9.8 meters per second squared. That is a vector quantity, and my point was if you just made it 9.8, it would just be not a vector quantity anymore, but a scalar one. Bad example. So speed, if I decided that I was going traveling, so I'm in a plane, I'm traveling down, and so I'm traveling down at speed of a plane. Who knows a good speed of a plane? Negative
6 miles per hour.
4 miles.
Okay, so let's say negative 200 miles per hour. Okay, that would be my velocity or my speed? Velocity. What would my speed be?
200.
Okay, so you don't take into account the direction when you're talking about speed. Okay, acceleration, again, is just the derivative of velocity. Okay, so like I told you, and I just kind of like to draw a little diagram, like normally you start with position, you take the derivative of position, you get velocity, you take the derivative of velocity, you get acceleration. So going down, those are derivatives. Okay, derivative of positions, velocity, derivative of velocity, acceleration. If you take that same process and go up, Going backwards, that's integrals. Well, that's not speed, that's position. But nothing. I have nothing for you. I have no physical quantity. Now, I can take an extra derivative of acceleration, and that's jerk, which is just the rate of change of acceleration. But I don't have anything past that. Yeah, it's an actual thing. It just means the rate of change of acceleration. So they actually don't want too much jerk in like roller coaster rides and stuff like that, because they don't want to jerk you too much. But and that too. There you go. All right. Okay. So again, if you look at this, if you take the derivative of acceleration, you're going to get velocity, but you're going to get plus a constant, and you're going to have a point to solve for the constant. And then take the derivative, the integral of velocity, you're going to get your position equation plus a constant. And like you said, we're not going to integrate position. That's not going to get us anything.
So the S there is for position, not speed?
Yes, it is. Okay. Now, if you have bounds on your integrals, so remember if I'm talking about bounds, I'm talking about it being a definite integral and you having numbers right here. Okay, so if you remember the first fundamental theorem of calculus, it's been a few days. If you integrate the derivative, you get the change in the original function. Okay, and so if you integrate velocity, that's going to be really, really important in all your motion problems. Okay, if you integrate velocity, velocity is the derivative of what? Position. Okay, you went the other way on the derivative. Okay, so v of t is the same as s prime of t, the derivative of position. This should have a dt on it, by the way. Okay, well, so this would be integrating the derivative of s, and so you get the change in the original function, s of b minus s of a. Remember, the s is representing position, so that's just final position minus initial position, which is displacement. So that's going to be really important because when you integrate a velocity function, you're going to find displacement. You're going to find how far you've traveled. Okay. Sometimes you're going to want to know how far you've traveled. Sometimes you're going to want to know the total distance you've traveled. You need to write these two things down. I'm going to show you how they work. Okay. So if you just integrate velocity, it's going to give you displacement. Your final position minus your initial position. If you want to find the total distance you traveled, you're going to have to integrate the absolute value of velocity. And I'm going to draw you just a little sketch before we work some problems to show you what I mean. But that's like the most important thing I'm telling you today. Also, I just randomly pulled a piece of paper out of somewhere in your notes between now and the rest of the year. That should be interesting. Thought it was just a scrap page. Remind me of that when I'm wondering where the next page is. I flip through, it's in there somewhere. Well, that's what I just did, so wish me luck. Okay, I'm going to draw just a little velocity versus time graph. So this is going to be time, this is my velocity. And I'm basically going to show you little integrals. So there I'm telling you, basically that information is if you integrate from 0 to 2 of that velocity function, you will get 5. So I'm trying to tell you that this area, I'm calling 5, made it up out of thin air. Just decided it was 5. Okay, if you integrate from 2 to 4, we know that if the curve is below, then our integral answer will be negative. So this is representing how you're traveling, okay? So for this, basically this would mean that I'm going 5, let's say meters forward, and then I'm going 5 meters backwards. Yes, that is another key point. Excellent. Okay, changes direction when it crosses the x-axis. Which is also when velocity is 0. That's going to be the way we figure out where we're changing directions if I'm given just the equation rather than the picture. Okay, So basically on this one, between 0 and 2, I'm moving forward. Now this is velocity. So if you look at it, I'm speeding up, and then I'm slowing down to a stop. And then I'm going the opposite direction, kind of speeding up, going backwards. And then I'm slowing down because I'm not going as fast in the negative direction. Okay, so you're looking at the values of it. Okay, the area under the curve is giving you the distance that you traveled. So on this particular problem, if I asked you for a displacement, okay, all you have to do is integrate the curve that I gave you. And when you integrate this curve, what are you going to get? Zero. Because this will give you 5. The integral from 0 to 2 is 5. The integral from 2 to 4 will be negative 5. Whatever that area is, remember that if it's under the curve, the integral is negative, even though the area is positive. Okay. Now, if I want total distance traveled, what I told you was that instead you're going to integrate the absolute value of this. Okay. Now, on your calculator, you can, if I gave you the equation, you could actually just integrate the absolute value of it, and it gives you the answer. It takes into account what's above and what's below. However, most of the time on your test, you can do this. Okay? On your test, you're allowed to integrate the absolute value. However, sometimes when you don't have a calculator, you're not going to be able to do that, and you're going to have to divide it up. Okay? And so for this, what I want to do is say I want the integral from 0 to 2 of the function. But then what do I want to do with this one? Yeah, I basically want to add the 5 instead of subtracting the 5. So anything that's below the curve, you're going to have to do the opposite of from 2 to 4. Okay, so that way the integral from 0 to 2 is 5, but you want to do the opposite of negative 5. So your total distance traveled is 10, and that just means you're going 5 forward, 5 backwards. You're back where you started. Okay, got a total of 10. So the key thing is going to be if they ask you for displacement, all you have to do is integrate the function. If they ask you for distance traveled, you're going to have to integrate the absolute value of the function so that you're adding it up whether it's positive or negative. And if you're doing it by hand, in order to know where to split it, you're going to have to know where the velocity is 0 so that you know which part is above and which part is below. You're going to have to do a sign chart. Okay, how are we doing so far? All right. All right, so here's a super easy example. It says, suppose a car travels at a constant positive velocity of 60 kilometers an hour for 15 minutes. What do you already hate? Yeah. Okay. We hate a lot of things. But the thing we should dislike the most is that we have different units for time. Okay, so hours and minutes, we're going to have to kind of do something about that. It says, graph velocity versus time and find the distance traveled and the displacement. So we're going to make a little graph. Velocity versus time. You always need to, on your, anytime you make a graph, you need to put the quantities and the units. So what units for velocity? Okay, and what do you want to use for time? Let's do it. That way they match up. I like it. Oh, I literally put the decimal in the wrong place. Sadness. Bless you. Bless you is usually used.
Well, no, he sneezed and he shook the whole table as I was writing, so now my 0 is super oblong and gross.
Well, see, what's good about this is if they listen carefully, they will actually get to hear the other side of the conversation instead of just whatever I say to y'all. So it's kind of good. I feel like it's going to be a good thing.
I didn't get it. I used the word.
Yeah, Tim hasn't even given us any sassy comments yet today. He must be still tired from this trip. Okay, I'm just waiting. Okay, so for this, it's just going to stay at a constant 60, and I really don't know that it's going to do that after 15 minutes, but I'm going to do a little sketch here. Okay, and the reason I'm doing a sketch is because it wants distance traveled and it wants displacement, and that's represented by the area under the curve. Okay, so displacement just means all I have to do is integrate it from 0 to 0.25 hours, whatever my function is, which my function is just a constant 60. Okay, which I can do that by hand, or I can calculate the area under the curve. I will be happy to do it either way for you. Just pick a way. Area or integrate.
Area.
Okay. So how do I find the area of this? Yep. And notice that it's nice that we have our consistent units because our hours will cancel. And what do you get? Come on, half 60 twice. There you go. 15 kilometers. Okay, so my displacement is 15 kilometers. If you integrate this, you'll get 60t, plug in your upper bound minus your lower bound, you will get exactly the same thing. Okay, for distance traveled, you're supposed to integrate the absolute value of that. Is it going to be any different? No, and you know it's not because it is entirely above the x-axis. If it goes below the x-axis at any point, then you need to split it, do the integral of whatever's above the x-axis, and to do minus whatever the integral is for anything that is below the x-axis. Yes?
Is travel spelled with 1 L or 2 L's?
Both. It's like a British spelling versus an American spelling. Both are accepted.
Yeah, which one's the American?
I think that I thought the British was the double L, but
In America,
it doesn't. I feel free to go back and forth between either one because they're both considered correct.
you use 2 L's when you say travel, 1 L when it's travel.
Well, this is why you're bothered. But both are Alright. Now, I don't know why, but I left a small amount of space for this next problem, and it actually needs a little more space. But I do have good news for you. I did decide I'm not doing this problem. So if you are trying to do some space, well, I was looking at how to slim down today a little bit, and this is the one problem I decided could go. Okay. Well, yeah, that'd be a lot of whiteout and a lot of dry. I don't know about you, but like whiteout never works for me. It just makes my paper worse. But I tell you that to I tell you that so you know that you can use this space down here if you would like to. Okay, so here we have, suppose a car is traveling at a velocity of 60 minus 600 t, and I need to give you some units, kilometers an hour. Graph velocity versus time and find the distance traveled in 6 minutes. Find the distance traveled in 9 minutes and the displacement. So what do you already not like about me? Minutes. They don't like the spelling of traveled. All right. So we need to graph this. What kind of graph is it going to, what's the shape of the graph going to look like? It is y equals mx plus b, so it's going to look like a line. I think I'm going to graph it down here because I'll have plenty of room. Okay. I know that it's going to, and I'll just write right here the velocity equation. Sure. Give me a minute for that. Oh, our classmates are, we have a picture of them.
Where they at?
They're somewhere. Ah, look right in front. There we go.
Yeah. Look at the whole gang. Rustin.
Wait, what are the rest of these people?
Where are the rest of the people from our class?
Wait, where'd Emily go? She just disappeared.
Emily,
She's writing a book in the corner.
She might be. I don't know. Anyhow, Mr. Evans sent me the picture, so.
I thought that math thing was just for like IBHL math people.
Well, it goes algebra 1 through calculus, and it has statistics too. So we have all sorts of folks. Okay. So here we go. This is what I'm graphing. It's going to have a y-intercept of what? 60. So I definitely know I'm going to have to be that high. This is going to be in hours, so I'm going to have to figure out about 6 minutes and 9 minutes. Okay, so 6 minutes in hours, 60 minutes in an hour. All right. Okay, 9 minutes. Yeah.
And when it says the total distance traveled, does that mean like total distance traveled in 9 minutes or in 6 minutes?
Oh, they asked us to do both. Well, it said distance traveled in 6 minutes, and then distance traveled in 9 minutes and displacement. So we'll just handle both. Okay, so it sounds to me like you guys, should we go by 0.05 then?
Yeah.
Okay. So 0.05, 0.1, and 0.15. And we'll just kind of make a note to ourselves. This is also our 6 minutes and our 9 minutes. Okay. So I think I'm going to make a little chart. Aren't you glad we have all this space now? Say yes. Make me happy.
Yes.
You're great. Okay. So I'm going to do, I definitely would like to know where I'm at 0, where I'm at 0.1, and where I'm at 0.15. 0 is kind of easy because that's the y-intercept. Okay. And so we need to put in 0.1. 60 minus 600 times 0.1. Where am I at then? Yep. 60 minus 600 times 0.15. Awesome. Okay, so that kind of helps me know what I'm going to do here. So I'm just going to go like 30 and 60, and I should put my units, kilometers per hour here. Got my hours there, and here I will have negative 30. So I've got 0, 60, I've got 0.1 is 0, and I've got my negative 30. Scared, I don't know if Luke will approve when I try to draw a line through this. Taking out the ruler. He's not even looking. It actually went through all 3 dots. Like, come on. Like, you're just going to not... Oh, no, oh, no.
I think you should be surprised.
Tim, you always support me when it looks terrible. What are you doing?
But now it's not as terrible, so you can actually be truthful.
Okay. Well, that tells me about my other previous compliments. They're all completely wiped out.
All your other ones are trash. You just want to be nice.
Yes, but that's okay. I like
I'm
nice.
learning to be American. Tell the truth.
Oh, dear.
Tell what's good.
Chill.
Oh, well. Oh, well. Just crushed my soul. Just, all right. Here we go. I know. Although, actually, I mean, I don't know. I got this cool pie. It lasts for a lot of... I can last through a lot of heckling for just one metal pie. All right. So let's see what we got. We got a nice drawing so far. It wants me to find, for 6 minutes, it tells me to find the distance traveled in 6 minutes. Okay, so distance traveled means I integrate from 0 to 0.1, because that's in hours, of the absolute value of my function. Okay, so I can either actually integrate or I can calculate this area, and I'm going to go for area because it's just a nice triangle. Okay, so for this area, I'm going to do 1/2 the base, which is 0.1 hours, times the height, which is 60 kilometers an hour. Three. Okay. Since it's already above the x-axis, I don't have to do anything different. Okay, this is just 3. It would be the same for distance traveled as displacement. So I'm going to say this is distance traveled and displacement is 3 kilometers. Okay, and then we're just going to do the same thing for 9. Okay, but they asked for a distance traveled and displacement. So I'm just going to do both in 9 minutes. take to grade Max's notebook. It's going to be an epic experience.
Oh, you did it. That sounds
All those things.
Yeah, it's on his calculator.
I have all the answers right here.
Uh-huh. That'll be very easy for me to grade.
That's just one mark. You have to show your full credit.
You're telling All right. So displacement, all I have to do is integrate from 0 to 0.15 of the velocity function. Okay, whereas on distance traveled, I'm going to have to integrate the absolute value of the velocity. Okay, you must remember the difference. Very important, particularly on the test that you're going to be taking soon. By soon, I mean whenever they actually let me teach you, which there's no telling. It really isn't. I looked at the April calendar and I was like, do what? Yeah, it's pretty bad. Okay, so I'm definitely going to need to know what this area is, or I'm going to have to integrate it by hand, one or the other. It's not hard because it's just power rules, so it's not like I'm avoiding it. Y'all have certainly integrated worse things. But I'm just going to find the area of this, so a half, that would be 0.05 times 30. I will wait for you to tell me what that is. Yeah, I lost Max on the calculator because it's taking notes now. Alright, so we got 0.75. Okay, so when it asks me to find displacement, which is just to integrate this, okay, what I would get when I integrate from 0 to 6, I would get what? 0 to 6 minutes. 0 to 0.1 hours, what would I get? 3. And then when I integrate from 0.1 to 0.15, what would I get? Well, negative, right? Because it's below. Okay, so basically that means I'm moving forward 3 kilometers and then backwards 0.75 kilometers. Okay, and so that's 2.25 kilometers. That's the same thing you would get if you just regular integrated this and put in the function 60 minus 600t. Okay. If it's the absolute value and you're integrating it by hand, you have to split this where it crosses the t-axis. Okay, where it changes direction. Okay, so I would have to integrate from 0 to 0.1, and then what would I have to do? Okay, do I subtract it? Good. Okay, because this, I want to add it up, even though it's going to be a negative. I still, even though I'm going backwards, I still want to add it as more distance that I have traveled. So for this one, the integral would be 3 minus this integral, because it's below the x-axis, is negative. So minus a negative 0.75. So that tells you that I traveled 3.75 kilometers total. So this is displacement. Compared to where I started, I'm 2.25 kilometers ahead. But I've traveled a total distance of 3.75 kilometers because I went 3 kilometers forward and 0.75 kilometers backwards. Is that all right? I'm going to work you hard today. I don't know what to tell you. It's just going to be the way it is. Is that all right? Yes, no, not quite? I'm sorry. When they actually let me see you, I'm going to just have to barrel through. Plus, I'm deserting you on Thursday, so. The motion worksheet that I told you. And possibly you might get the review guide for your test, although you'll have a separate day to do it. Good? All right. Okay, always exciting in math class. Imagine a particle moving in a straight line with a velocity function. There's something wrong with my velocity function. It's an error that I keep forgetting to edit. Please find the error with my velocity function. It's the units of acceleration, right? So this is no good. I'm going to make that to the -1. It's supposed to be centimeters per second. I had centimeters seconds to the -2, which would be centimeters per second squared. Okay, so that's just supposed to be centimeters per second. So that's my equation. It wants to know how far it travels in the first 4 seconds and what the displacement is in the first 4 seconds. And I'm going to give you a minute to try to figure it out. So go for it.
Does this take up a lot of space?
No, it does not.
You're good intro.
Alright, so welcome back to Matthew Cathy's math class. We're going to be doing this problem right here. It doesn't have a problem number, but we're just going to do it. So, yeah, example dash A. Particle moves in a straight line with a velocity. Alright,
It just says example, a particle.
well, there's a dash. I had to read the dash.
There's not space and the A is not capitalized.
That's how you
I
read
understand,
dash.
I
You don't just
understand
say
you,
it.
Jake.
You don't announce dash. It's like not announcing a comma or not announcing a period.
Oh.
However, comma.
Alright, Edwards, let it work.
Alright, so first thing I did was draw this velocity graph, and you can draw it kind of funky because you know what's going to happen. So,
Real funky. You already know how to do it.
so it starts at -3, that's your y-intercept, because at a t of 0, well, let me draw my t and v, t, in kilometers, not kilometers. So if you plug in a t of 0, you start here, and then you go up by 1, so at a time of 3, you're going to have 0, and then you're going to go all the way up to here, and we're going to draw a straight line that is definitely not going to hit these points. Alright, look, it hit all the points. So, we're going to find the area of this right here, and the area of this right here. And so, if we know our basic triangle formula, which is 1/2 base times height, this is 3 times 3, so that's 9 times a half is 4.5 for that one, and this one is 1 times 1 times a half, so that's 0.5 for this one. So if we want to do the total distance traveled, we can just add them together, because this is going to be a -4.5 and then back 0.5. So that's just going to be a total of 5 centimeters. And if we want to do the displacement, we just subtract them. So it would be moving backward. It would be moving backwards 4.5. So moving backwards 4.5, and then moving forwards 0.5. So that's just going to get us a total of -0.4, or -4, centimeters. And that's it.
Questions? All right, hang in there. We got 3 more. Can you do it? Say yes.
Yes.
Right, that was so great. Okay, this one I'm going to do without drawing a picture, although we could. It gives me a velocity function. What's different about this velocity function? It is quadratic, okay? It wants to know how far the particle travels in the first 4 seconds and the displacement after the first 4 seconds. Now, here's the thing. Displacement, I already know I can integrate from 0 to 4. Okay? I'm just going to write this down. Displacement, I can integrate from 0 to 4 of this function, and that'll be the answer. But, for distance traveled, dealer's choice on number of L's, I'm going to have to integrate the absolute value. Now, right now, I could do this on my calculator 2 seconds to tell me the answer to both of them. Okay? However, I am not allowing you to do that with the absolute value. I want you to know where it changes directions so that you could do it by hand if it's paper 1. Okay? On your test, you have a lot of leeway. You have a calculator in your hand. You can integrate absolute value. Get full marks. Okay? So this one I already know what to do. This one I just want to be able to divide up. In order to find out where to divide it up, I need to figure out where it changes direction. Is it moving forward all the time, or is it sometimes moving forward, sometimes moving backwards? And how you decide where it switches direction is when the velocity is equal to 0. Okay, so I'm basically going to make a sign chart for velocity so I know when is it moving forward, when is it moving backwards without a graph. Okay, so I'm going to take velocity and set it equal to 0. So I can find those places where it changes directions. Help me solve that. Okay. So it's basically going to change directions twice. Okay. I'm going to make a sign chart for velocity. And I know that it's going to be 0 at 1. And 0 at 2. We can use Eleanor's rule. I was hoping you'd remember. Okay. So you can test in between the intervals, test into the velocity function and see if it's positive or negative. You could substitute in a point here, a point here, a point here. But Jake has already pointed out this is Eleanor's rule. We do know how a quadratic behaves. It has a positive leading coefficient. So what would my signs be? Yes. So if you remember, Eleanor's rule is just saying, hey, you know it's got a 0 at 1 and a 0 at 2. If you know it's a parabola going up, it's going to have to be above the x-axis, below, and above. Positive, negative, positive. If it had been an upside-down parabola, it would have been negative, positive, negative. Okay? So we actually kind of have a sketch now of this. Okay, but we don't really need it. Okay, now we know we don't care about this time that we're not doing. We don't have a TARDIS or anything. We're not going back in time. Okay, so we only care from 0 forward. So for this one, if I want to find the distance traveled, tell me what kind of integral I would set up. For distance traveled. In other words, how am I going to find this absolute value? Where am I dividing it up? Which parts am I adding? Which parts am I subtracting? Okay. Perfect. Alright, and I apologize, I ran out of room. This should all be on one line if you can make it work. Okay, so that's the idea. Here we're moving forward. Here we're moving backwards, but we still want to add it. So I know this answer would be negative for the integral, so I want to do the opposite of it, plus this. At this point, once you have shown me that, you can substitute it on your calculator. Okay, so will I know if you put it in here, or if you put it in here? No, I'm not. Okay, but I am going to know, did you write down this is distance traveled, and then did you show me how you broke it up, and then give me the answer. Okay, so let's make sure that we can put that on the calculator. This one, I just put that in. Okay, there's no trouble on there. So let's make sure we can do that real quickly.
So on a test, we would get the marks off if we didn't split it up?
No, only on paper 1. And when I give you this test, you can assume it's like a paper 2. If you have a calculator in your hand, you are allowed to use it. That's kind of the deal. But on paper 1, you're not going to have a calculator in your hand, so you're not going to be able to. But I think it's pretty clear on my test where I try to be clear about taking advantage of the calculator. And my calculator has to wake up. But please do put these in. I'll put them in here in a second. But all you have to do is put in 0 to 4 of the function and 0 to 4 of the absolute value of the function to get our 2 answers.
So is that all we need to do on the test, is like draw the graph and then show that we took the integral, the absolute value, and then the answer?
Yep. But on your homework, I'm going to need to show you. I'm going to need you to show it split up, and then the answer, so that if it's a paper 1 without a calculator, I know you can do it. so you need to integrate from 0 to 4. If it's absolute value, you can hit this little guy right here, and you can hit this template for the absolute value, or if you want, you can do ABS parentheses, and that'll work. And we're going to put in t squared minus 3t plus 2 dt. Okay, so that looks to me to be 5 2/3. What do you think? Okay, and then just do this. Did you guys already do the same integration without the absolute value? What'd you get? Excellent. Okay, so if you do the same thing without the absolute value, Sydney's already told me 5 1/3. So those are our 2 answers. Hang in there. We've got to make it through 2 more problems. I think you can do it. It takes stamina today. You're the only class I get to teach today. The seniors took a test, and then the seniors after you are all presenting problems, so I get to watch them teach all day. This is my only shot today. Yeah, they're presenting. So, like, all the problems in a full-length paper, I've split them up, and they're presenting. This is my last hurrah, 2 problems. I get to sit down and let someone else take the wheel.
Oh no!
By the way, this isn't.
Oh no!
Okay, Tim is beating his head against the wall. Don't let that disturb you. However, this is just an SL problem. Just an SL problem.
This is an SL problem?
Yeah. Yeah. Took it out of the SL book.
G steps.
Yeah, it does have G steps. Steps, yep. Alright, so let's take a look. It says the velocity of a particle traveling in a straight line is given by that equation, where time is greater than or equal to 0, time is in seconds. Very first part, don't be scared. It says state the initial velocity of the particle. Does that require calculus?
50. Just 50.
Oh, jeez. I don't know if y'all are right, though.
Oh, no, I'm not right.
No, E is like 2.71. It's the real E. There you go. Yes. Okay, so we're just substituting in 0, so negative 0.5 times 0 is just 0. So e to the 0 is just 1, so 50 minus 10. We have 40. It appears our units are meters per second. See, not even calculus. Baby stuff. Okay, it wants the velocity after 3 seconds. So what am I going to do? Yeah. I mean, so you just need to put that in on your calculator. You're not expected to know what e to the negative 1.5 is. But I will wait for you to tell me.
I thought that was E7.
Do you know what it is now? See, we're already on C. It's all good. How long will it take for the particle's velocity to increase to 45 meters per second? What am I going to do? You could, but I'm not going to. But what equation would I be putting into NSOLVE if I was? Well, okay, so we're just setting the velocity equal to 45. We're going to solve for time. We are not going to use unsolve. We're just going to solve it. So tell me how to solve it. Yeah, don't do ln until you get the exponential expression isolated. Still wouldn't do it yet. Yeah, but I'm also going to divide by -10. I'm sure it did, but I expect more out of you. All right, then what? All right, so ln of both sides, or just change it to log form, your choice. But these undo each other. They're inverses. See, this is your brush up. You need brush ups on your old skills. Okay, so ln of both sides, ln and e are inverse operations. Last thing is just to divide by negative 0.5. So time is whatever that is. Okay, which is what? Yes, but I just want a decimal.
1.4 or 3.8.
I just want 3 decimal places. Okay, is that all right? Okay. Let's see a couple more pens moving, so I'll wait a second. Okay. D says discuss velocity as time approaches infinity. And then F says draw the graph of velocity against time. So I'm actually going to tie these two together. Okay. Well, yep. Okay. So we're going to graph velocity, and thus we're going to figure out what's happening to it as you go towards infinity. I'm not going to use my calculator to graph it. Stuff and nonsense. All right. Y'all sound excited. You sound pumped. Okay, so this is what I'm trying to graph. Time. It's very fun. What are you talking about? Okay, so I want you to think about what this is going to look like. So first, what I want you to do, actually I'm going to put a couple things. I'd like to know what this is. It's just a number. Yeah, I'm going to use more room than I have just to kind of get the idea of all this. I would like someone to come up and graph what a sketch of e to the x, then a sketch of e to the negative x, then a sketch of negative e to the negative x.
I guess those have been chosen.
Do the third one.
Oh, dang it. Hey, no, put your calculator down. Luke.
Absolutely
You told
not.
me to calculate it.
Luke, put your calculator down.
Wait, should I, is it just, oh, it's just a sketch.
Push it down, Luke.
Big shit. Ugh. I'm still gonna try.
Yeah,
What?
Luke's just gonna
So do I need to, like, make numbers or
No,
just
I
sketch
just
it?
want to see
Who
it.
knows?
Just
What
different.
take was, that's what we're gonna put.
Max, draw it right now.
We got that one. That one's easy.
Yeah, I don't know what it is.
He's like, but I'm going to figure it out.
Yeah, I got it.
Do you really?
No, he doesn't.
I
don't.
Yeah, Jake, you go first.
Is this something like,
I think it's gonna
I
get like
can't,
a.
I don't know what e to the x looks.
I think it's
Should I just go
it's
for all of
that.
I think it's like the
starts
Nike
here,
swoosh.
and then it just goes,
See, that's
just
what I was
goes
thinking.
out.
That's what I was thinking.
And so this one does the
Hey,
opposite.
But you gotta mark that it's a 1 on the y-axis.
It's
This
a
is
sketch, David. There's no numbers.
This is just a guess. No?
Dude, do you remember ninth grade?
What kind of reflection over what?
Do you remember ninth grade?
Y-axis. You're trying to
So am I just doing that or something like that?
Boom.
That's the x-axis.
Okay, now we got
I
to
know.
take loops, and what do we got to do to loops?
Flip it over the x-axis.
There you go.
That's what I was doing the first time.
Yeah,
Oh, I got a team.
Well, Max, your drawing
Alright,
up
I
here
got
looks really good.
Yeah?
Uh-huh.
better than yours. Rather have got nothing than yours.
What about my crazy? What about it?
All right, looks good. That's what I want.
Oh. Yes.
Oh, don't forget your calculator up there.
All right, that doesn't matter. Some moral support. All right, so this is what e to the x looks like, because e to the 0 is 1. Just kind of goes up. This is reflected over the y-axis. Okay, that's what the negative x does. If you put a negative in front of the whole term, that's going to then reflect it over the x. So this has been reflected over the y and then the x. Okay, now all that is just to kind of tell me the general shape of that. Include the negative. Okay, notice that all of these reflections did not change the horizontal asymptote. Where is the horizontal asymptote? Yes, the x-axis y equals 0. Okay. The only thing that can affect it is if you move it up and down. Now, this little negative 0.5 is just going to affect how fast it rises. Okay. The 10 is going to have an effect. Okay. But not in the shape particularly, just how fast it rises again. Okay. What does the 50 do? Moves it up 50. Okay, and so anytime you add or subtract something, it just makes a big vertical shift. So I'm basically going to have this shape, okay, but I'm going to have an asymptote at 50. So that's what I'm going to draw, is a nice little asymptote here at 50. And I'm going to have this same shape.
Excuse me, could you just say that in school? You can't do that.
Okay, now, I do know something else about this. So this is v of t, this is t, velocity is in meters per second, time is in seconds. We did figure out what the velocity was at 0. What was it? 40. So this is 40. And that's my sketch. It's a pretty good sketch for not having a calculator. Okay, so what it's asking me now is to discuss velocity as time goes to infinity. That's basically this, the limit as time goes to infinity of velocity. Okay, so all that means is look at what's happening on the far right of your graph. Okay, so as you go towards infinity, what's happening to the y value of this function? It's approaching 50. Okay, remember that the behavior towards infinity is the same as your horizontal asymptote. This is flattening out at 50. Okay, so we have answered D and F. So basically, that's like a terminal velocity. Okay, so this guy is speeding up, but only to a certain point. Okay, so next we just got E and G. It's going to take us like 2 seconds. It's going to be great. It says, show that the particle's acceleration is always positive. So I'm going to go over here somewhere. Okay, this is my velocity. I'm just going to write that again. It wants me to show that the acceleration is always positive. How do I find acceleration if I have velocity? Okay. So what's the derivative of 50? 0. Okay, now what about the derivative of this part? Okay, well, you guys are right about the 5, but if I sort of think of it as I leave the negative 10, and then to take the derivative of e to the something, times the derivative of the exponent. Okay, which means you guys were right about the 5. Now, I can take advantage of the work that you guys already did. Okay, so this one is going to look like this one. Okay, because it's e to the negative something. So the basic sketch of this, and this would be 5, is it would look like this. So I have shown it is always positive. It never equals 0. If I try to do a sign chart, it doesn't have any spots where it equals 0. It is positive all the time if you test one point.
So on the test you must write the derivative of this is always positive.
Yes. Yes, and that would be enough information. The last thing, G. We made it to G, Tim. Are you ready? Find the total distance traveled by the particle in the first 3 seconds of motion. So distance traveled, is it going to be the absolute value or the regular? Okay. From 0 to 3. Now let's take a look at our function. We sketched it. From 0 to 3, does it change directions ever? No, it's always positive. It never crosses the x-axis. So this would be the same as just integrating it. Okay, because it's always positive. So we're just going to put that in on the calculator. These are equivalent in this particular case because velocity is positive on the whole interval. And you just got to stick that on the calculator. You could integrate it by hand. It's not impossible. I believe it's 134.5. Okay, and that would be meters. And we got to make it through one more problem. We can do it.
That took him 20 minutes.
If you make it with a smile on your face, you can all have a piece of candy. You don't have to smile at the end. It's okay. A frozen smile, that's just getting creepy. All right, we okay with this? Last one. I know it's a lot of lecture. I don't know what to tell you. That's right. 130. Oh, they got you. All right, this isn't too bad. It's only got an A and B, Tim. We're going to make it. The motion of a falling parachutist is modeled as linear motion by considering that the parachutist is a particle moving along a line whose positive direction is vertically downwards. Okay, so starting where whatever his motion is, we're calling down positive. The parachute is opened at time equals 0, at which time the parachute's position is s equals 0. This could be important. Okay, so because I'm going to be doing some integration, I'm going to need to solve for c. They're giving me a point there, essentially. According to the model, the acceleration is given by this equation. Okay, so out of all this paragraph, as you say, all you need is this is acceleration, and s of 0 is 0. At time 0, you're at a position 0. At the moment the parachute opens, the parachutist has a velocity of 42 meters per second. They're trying to tell me something. Okay, they're trying to tell me that the velocity at time 0 is 42. Okay, because the time is starting when you open the parachute. Okay, so I've actually got two pieces of information here. Okay, that we're calling the position 0 when you open the parachute, and at that moment you're already traveling at 42 meters per second. It wants you to find the velocity function and say what the model says about the parachutist's velocity as time goes to infinity. I have acceleration, I want velocity, what do I need to do? Yes. So velocity is the integral of acceleration. I'm going to go ahead and take the negative 54 out. And just put this. Okay, so what's the integral of e to the x? E to the x. But I don't have e to the x, so this is basically a u substitution. What's u? What's du? Do I have it? I do not. But it's only different by a constant, so I am not afraid. Do you want to do it with decimals or with... okay. That's going to look gross, I'm just going to warn you. So this would be 1 over negative 1.5 out here. See, if I did fractions, it'd be negative 3/2, negative 2/3. Don't want to change your mind? No, change your mind? Sticking with it? Okay, that's fine. Alright. So now I need to know what negative 54 divided by negative 1.5 is. Okay. So that's just taking care of this. Now this is, do you want me to rewrite it? E to the u du? Yes, no, maybe?
Yeah.
Okay. And so the integral of that is just e to the u, but I'm going to go ahead and put back in what u is. So I have a velocity equation. It is not very satisfying because of the plus c. Lucky for me, they gave me a point. Which point will help me figure this out?
42.
The 42, yeah. Since v of 0 is 42, you can put in 42 for velocity and 0 for the time and solve for c. E to the 0 is just 1. Subtract the 36 from both sides. That's usually the math I miss, to be honest. It's usually a negative sign or a subtraction. Every once in a while something serious, but not usually. So I'm now going to write the velocity equation over with what c actually is. Okay. Now, it also asks me to, what does that model say about the parachute's velocity as time approaches infinity? Now, we already did that shape. Okay. So, yeah. Yeah. A 6. Is that okay? So I put in, instead of the C, I substituted in 6, since that's what I found.
Yeah, I thought so, but it looked like the C at first, and then it was
Well, there's no telling with me. Some of my stuff looks the same. Okay, so if we think about what this looks like, okay, we know that this is e to the x. We know this is e to the negative x. Okay, so what would e to the negative x plus 6 look like? Move it up 6, so it would just look like this. Okay. So that's just a little sketch of that. Now this initial point is quite a bit higher than 6, okay, because if you put in 0, well, you know what it is, it's 42. So this spot is actually 42, so I need kind of, I'm not very much to scale there. Would you like it better scale? Okay, if Luke says it's okay, then it's okay. Break. There you go. That's all good. Either bigger dots or breaks in the graph. Okay, so the limit as time goes to infinity of this guy is just 6. Because that's what it's flattening out to. A couple ways to look at it. You could say the limit as t approaches infinity of this is 0. And then the limit as t approaches infinity of 6 is 6. Or you can look at the whole graph holistically. And basically, if you're doing an exponential function, it's always going to flatten out at whatever your plus or minus is. Okay, nothing else that you can do to this changes the asymptote from 0, but this changes the asymptote. Okay. All right, we got that. You ready? B, it wants the position function. What do you think I'm going to do? Integrate one more time and plug in that point, and we got this. Okay, so S of t, which is the S is for position, we're going to integrate velocity, and velocity was all of this business. And I can't use a calculator because it doesn't have bounds. So I'm going to take out the 36 from this guy, and I'm going to separately integrate the 6. Okay, because when it's plus or minus, you can separate each one. Now this is the same u substitution we already did, so we should be kind of good at it. Do you want me to write out the u and all that? Okay. So that's u. You don't want to, you don't have to. That's du. Okay, and so we're still sticking with our, we might as well stick with our decimals at this point. We need a negative 1.5, so 1 over negative 1.5. And I think that's 24, negative 24. Integral of e to the u, all of that's your du. What's the integral of 6? Perfect. Now that's t. That's a c. That's a 6. You're welcome. Sometimes some of these things, those are plus signs. It's kind of bad when a lot of them look alike. Okay, so this would be negative 24. Integral of e to the u is e to the u, but I'm going to put back in what u is. Plus 6t plus c. One more thing to do. What is it? Find c, s to 0, 0. Pretty serious stuff. So 0 equals negative 24 e to the 0 plus 6 times 0 plus c. E to the 0 is just 1. What's c going to come out to be? Yes, 24. So the final thing can find it, is this with a 24. And that is it. And that is your homework. And you can go get your candy.
Multiple